Hello and welcome, dear viewer, to the second video on Powder. Today, I actually want to start with a lexer for Powder. So what we have here, of course, is a very simple Powder program. Doesn't actually do anything, but it's a start, and I sketched that out in the last episode. I had some thoughts about what I wanted the language to be, so now we can start with lexing it and parsing it. So first, of course, a lexer. A lexer is the thing that that splits up this character stream into like the smallest unit of text that, or the smallest unit that the language recognizes. And those are called tokens. So for example, the entire comment up here will be a token. Function is a single token. Main is a single token. The open bracket is a single token. The close bracket, and so on and so forth. So I hope that we can get this thing to lex today. Probably not to parse, but to lex. So let's actually start by creating a cargo, a Rust crate, not a cargo, a Rust crate for that, but we're going to need the command cargo init. And I wanted to call it powder bootstrap. Should be a binary. I think the default toolchain, like the stable toolchain, would be fine. Let's do that. Okay. Let's check the cargo toml. Let's immediately remove those. We're going to need dependencies later on, but not right now. So I think we can keep this as is. Is there a repository? That would be https github.com/power. Never mind, actually, that's not put in the thing, but in case I publish this to like crates.io or something, this should just work. Okay. Okay, my Rust language server is already running and has already compiled stuff, so we need to make sure that we don't that we don't commit all of this. So let's create a git ignore real quick. That should exclude that. The cargo. Oh, right. Okay. I already have that here. Okay. Powder bootstrap target. So then we can delete that. Cargo lock. If creating an execute. Oh, right. Yeah. Have to keep cargo lock in if we're creating an executable. So yeah, that's powder. That's the cargo lock for powder bootstrap. Okay, let's look into the main file. So I'm not going to do like a clean separation of library and application package or anything like that. I'm just going to do a single Rust crate. So let's create lexer and have that thing in here. Also, before I forget, deny clippy all, clippy pedantic and clippy nursery. I prefer to, like, first of all deny all of them, and missing docs also. Powder bootstrap compiler. I like denying all Clippy stuff first of all, and then later like re-allowing some of the false positive stuff. Let's see how much of that we get, but in general I think it's really good to have that. Okay, so we have Modlexer. So the lexer module will first of all get a enum token type, and the token type, let's see what we have back here. Let's do this. Comment function identifier open parenthesis close parenthesis open what is it called, brace, close brace, const var colon n64 equals integer literal semicolon. So you can see there's like a mixture of these. Is it telling me? Okay. There's a mixture of like stuff like keywords, identifiers, built-in type names, literals, and just like syntax stuff like the equals and the brace and the semicolon. So maybe we can sort those. Comments. Function const var n64, that's a type keyword. And I'll only do like the bare minimum to parse this file for now. Then we have the symbols, which is basically everything else except for the put the identifiers up here. I don't know, I just like this order. Okay, so colon equals semicolon, yeah. Okay, and those are all symbols. So let's see if Rust format likes that. Okay, right, I don't have a Rust format install yet, but I don't have a Rust format config because I don't like some of the default configuration of Rust format, but I think that's fine for now. Let's do pub struct token. And a token will have a type, an underscore type underscore, because underscore in the beginning means this is unused. Token type. And also before I forget, let's put a wait, no, I mainly need a wrapper U64. Let's do that actually, so that we know that it's 64 bits or 8 bytes. Okay, type and token type. Now we need the contents, and maybe we also want the position in the source code. Maybe we just want to store like the start and end index in the source code and then have like one central source code object that we reference. That would probably be a good idea. Okay, so start usize, end usize, code, which is a let's actually do string for now, or sorry, end string, which means we're going to need a lifetime. That should be fine, because like we don't need reference counting at this point because the tokens don't live as long as the string. Yeah, cool. Okay, let's already do some Impul here. I think I need that. I always forget the syntax. Yeah, that's it. Okay. Pub of n new type start use size end use size and code a string which will create a self of prime a, and we need to use a different lifetime here, and this should be self capitalized. Why is not liking that? Because I need to I always forget how this works. Probably here somewhere. No. After the function name. After the function name. Cool. Let's actually make this a lot smaller. Why is that not liking me? Oh yeah, right, because the return is not correct. Okay, so we can simply construct a token that I'm actually thinking maybe we don't even need this function. Maybe I just want, no, okay, let's actually make those public because like it's all my code. I can just construct the token on as is. So then we have nicer syntax because we can like declare the fields in any order. It's more readable that way. Okay, what we do want is a text. Let's call it text self, and that's a string slice that lives as long as we ourselves live, because it's again referencing the string thing here. Okay, so let's do self.code.slice. Get, I think, a subslice, which is probably going to be a string. This is a bit confusing, and otherwise we can just get, so we can get from start to end, then dot expect invalid token from to, can I do that actually? Self.start, self.end. This definitely needs a self. And why doesn't this work? One argument, yeah, right, okay. Format. So good error messages are always important. And also remove that. Okay, cool. So now we can easily extract the actual text of the token, which is very important for things like literals and identifiers and so on. Let me actually put the literal up here. Okay. So what do we need next? I probably want like a parser state, lexer state thing. can probably lexer state, or do I actually need to have a struct for that? Yeah, probably if I want to like create sub methods. Let's see. Struct that doesn't need to be public. State, and lexer state now owns the string. Code string and a pub current position, which is usize. That might be enough. Okay, let's just try writing a parser function here. A parse lex, and that takes in code, which is a string, and it returns back a vec of tokens. And we might need to give those a lifetime. I mean, we're consuming the, we can't do this because the lexer state. Then, okay, well, let's say that we pass the string in by reference, and that the tokens then can take over that. Can just copy that thing, and this is, yeah, return type. Let's just actually like new that very quickly so that we get type checking. Yeah, okay. Okay, so let's I already need a function that I need for the lexing loop, which is the isEnd function. IsEnd self, which tells me current position greater or equal to self dot current position greater equal self dot code dot length. Okay, so let state equals lexer state. We move the code into this. Oh wait, how do you want the tokens to reference this string? So I think, yeah, okay, I think it's fine if we have that thing take a lifetime parameter as well, and then just have that copy the lifetime here. Or maybe it will automatically do that if I do code. Yeah, that's of course. Then we have current position as 0. I know I could do like default stuff. Okay, it will take, let's see, it will take the, it doesn't show me, but I think it does. I need a lifetime here as well. I think it should take the code's lifetime, because that's the only thing where the lifetime actually matters. Okay. Let's see. While state isEnd not. Okay. Now I could say something like skip whitespace maybe. Okay, let's sketch this out. State skip whitespace. It's to be mutable. Pub fan skip whitespace self mutable self. Just yeah, let's do this. I think we can do this, I believe. So while the current position, so the current position is like we'll need this in a minute. current char self, which gives us a char self dot code dot chars char indices. Wait, no. Can I not just like indexing? I think I need to index actually. Just code index after, oops, current position. Can I do that? That gives me, oh wait, that needs to have get, I think I need chars the iterator over the chars dot get set at, I don't know. There's something to just get the position, no. Nth, that's it. Chars.nth, yeah, I always forget. What does it tell me? Expect, yeah, right, invalid. Lexer position self.current current position. Okay, and of course we need to format this. Format. Here we go. While self.current char dot is whitespace, probably, yeah, any Unicode whitespace. So Rust gives us that for free. Self.advance. So that's, wait, let's put that, yeah, let's put it down here. Because those are all the like immutable functions, just the property getters basically. Now we want the actual mutating functions. Advance self. What do you want to return? Nothing actually for now. Self.current position plus equals 1. Cool. Okay, self should be fine. Let's actually do that here as well. I always like that. Like when functions that that don't return anything, they just return the object itself. And I think I'm going to make that the default behavior in Powder now that I think about it. So basically, if you have a void method, it's not really a void method, but a method that returns the object itself or a reference to it, which allows it to do like chaining. For example, for this advance call, we can just self.advance.advance.advance and so on. We can just do that again and again, which is really convenient. Like it allows you to write code much more concisely. Okay. Yeah, okay, skip whitespace. State skip whitespace. Let's actually print line the state.current char. Self.isEnd, we probably want to check that here as well. So if we're at the end, we don't. So basically, if you call skip whitespace on a lexer that hasn't, that can't advance anymore, it doesn't do anything. Maybe we want to actually print out like a failure state or something. let's try this. If okay, so advance will always advance the current position, but if we're at the end, which might even mean that we're over the end, we can just return nothing, none. If self that is end, none, and else some self. Okay. Yeah, we have a failure here, up here, panic, and we could like, yeah, we could check this here. I think we can, yeah, we can just do that. Oh, that's super clean. That's like super clean. While it's white space and the advance is successful. Wait, we need to actually invert the condition, because short-circuiting stuff will hurt us here. If while self advance is some, okay, we advanced, cool. If the sorry, I'm going to do this because it's clearer, because I think there's a bunch of edge cases where the other one doesn't work. So let's just stick to that. Okay. Yeah. Okay. Now we need to peek at the next token to find out what actually is the next thing. Okay. So I guess we can, like, first of all look at the character class. For example, if we have an alphanumeric character, we'll definitely have either an identifier or a keyword, or a type keyword, which I'm calling this. So we can then check like the list of type keywords or something. So actually, can I import token type? Is that even possible? It is. I've never written functions for like these primitive enums. Function. Keyword. Let's say string. Let's say that we match string, and this returns a token type, optional token type, and the default is none. And if we get function, some function, if we get const, some const, self const, self, and this is going to also be self. Okay, var some self var, and let's actually also put the type keywords in here. So let's have n64 some self n64. Okay, I think that's all. Let's actually put the type keywords up here with the keywords. so that I can see this better. Okay. I'm already at 30 minutes. That's fun. Okay. Now we can get a. Let's take, by the way. Now we can get a keyword. No. Let's actually look at the next character first of all. Match state current char. If we get a slash, then we parse comment a lex comment the state. That will be a function we're going to write in just a minute. This needs to be a character, of course. Now if we get, no, I don't know, A through Z, is that even possible? Like lex token type from keyword. Just for testers. No, that doesn't work actually. Oh, exclusive range pattern syntax. What about the the inclusive one? Oh, right. All right. Oh my god, I didn't even know like that this was actually supported. We're going to have a lot of fun here, guys. Okay, let's say that that like these alphanumerics can start with A through Z, and an underscore maybe, underscore. Then we're going to do some more complicated logic. So we're going to have the let word equals state dot next word. And then if let some keyword is token type from keyword, the word, then we're going to have append a keyword to our token list. So let it tokens vec new. So we can tokens append let's push probably. I don't know. I don't remember. Yeah, okay, it's push lexer state. Not lexer state, token, and the token start is the start is the state dot current index, current position. The end is the state current position plus the word length. The token code is code. Copy, and I can actually put token start here. And the final thing that's missing is the type, which is this keyword type. It's maybe okay. Yeah, the Rust language server sometimes can't do these renames. Like if you're in nested patterns and with if let pattern matching, that's sometimes a bit hard. Okay, method next word, right? We have to write that, and we also have to write the lex comment. Okay, let's try writing lex comment actually. Or maybe, no, maybe I want to actually put that in the code here and maybe we can refactor it later. Okay. Okay, let comments is state current char. Char is new line. Does not equal. Let's just handle normal new lines here. So we need to change this thing to line feed first of all. While there's not a line feed, while it's not a line feed and we're not at the end, we can advance and we can comment dot push append whatever, append the state advance current char, and that's what I'm saying. I can just chain those together. That's an option. Should be safe to unwrap here because I'm checking his end explicitly. If we're not at the end, we can advance. And this check needs to happen beforehand. So yeah, okay, so we can advance towards the end, and that's completely fine because then we're just indexing. Oh no, that's actually not fine. Then we would be indexing like past exactly the last element of the string. So okay, so if let some state equals state dot advance. Oh right, no, I don't even need that. I just need is some. Then I can append the comments current char else break. Let's see if the formatter catches that. It doesn't. Just do some basic formatting for now. No method named append found. For type char, that's a string. From char. Cool, that exists. Probably can't append because string builder or something. I don't know. Let's see. Why is there no semicolon here? Okay, now the formatter works. Is that in string builder? I don't know. Do we have like a string? Don't we have like a standard? Oh, here we go. Probably. I don't even know. there like a Rust string builder standard type? String is heap allocated global and non-null terminated, right? So it should be fine to append to a string. Let's just look at insert, right? Push, and push stir. Okay, I can just use string here. Push. Cool. So we can do that. In advance. And then we want the next word thing. Wait, no, let's finish that first of all. Okay, we have a comment here. So let's actually print line. Font comments. So I'm going to just for now so that I can test this. Real quick font comment, that's comment in quotes so that we know where it starts and ends. And now I can add this. Insert push token, okay, start state, which is not the current position anymore, and I'm just okay. Let me just. I need to store the current position for that. Okay, just do that. Which should be the current position, by the way. Okay. Current position, the code is still code, and the type is token type comment. Okay. Now let's quickly write state next word, and then let's try that out because it should be able to parse until here. State.next word. But then wait, no. Let's put that up here with a skip whitespace. Next word. String stir. Self. Mutable self. Let start equals self dot current position. Now let's not actually, like, why are we pushing this anyways? Let me just quickly go back here. And do this because we don't actually need the comment. We can just do state dot code that gets from, no, I can just use indices because I don't care about errors here. That's just debugging code. State current position. Okay. Yeah. And also I need to check that the next slash is actually a slash. Let's not worry about that. Fix me. Push between slash and // yeah, let's not worry about that. We don't have any slashes, any single slash in the test file. Okay. Current position. Let's go back to next word, because that's all we need here. Okay, so while current char is alphanumeric, alphabetic, alphanumeric, or self.current char is equals underscore. Let's say, I think that's all the characters we want for identifiers and keywords, underscores and alphanumerics. And like we already checked down here that the next word thing, where is it? Next word, we already checked that the first character is not a number, so we can only works correctly if the first character is already checked non-numeric. Yeah, okay. Let's just remind ourselves of that. Self.advance. Do we actually want? Oh yeah, we actually need the string, right? Net self current char from self.advance, and then after the advance we added, no wait, we add before the advance and then we check again. Yeah, okay, so I need to create a new string and then word push self.current char advance and although no, right, I don't need to do that because I can just take the slice in the end. So self from start to the current position, which should be self.code, of course, which complains about being not a borrow. Okay, now we don't check while it's alphanumeric or underscore, and also we need to check while we're not at the end. Okay. Cool. Just say blah of type blah. Okay. Some keyword type. Need to do that down here. That's not debug line. It's not Serenity. It's print line. Word and keyword type. That thing is not display, so we can just derive display debug. We can't derive display because I don't care actually. Let's actually do a clone copy here while we're at it and derive debug for this as well. we're going to need it. Going to need it. And for this. Debug. Okay. Now this, yeah. Okay, we need question mark. Okay. Let's try running that in the main function. Let's first use std as read to string, I think it is, path, then yeah, that's like the quickest function to. Okay, and then we pass the argument, the file as an argument. So we probably need std and rx. So let rx equals rx. That should work, I hope. Yeah, sick. Why is this on 4 spaces? This should be on 3 tabs. Yeah, okay, now it works. So I don't even remember what the args like. What are they? First element is the path with executable, and the second argument is probably the other one. Okay, so let's see. We want file name is args index 1, something like that. args.nth. Okay. Expect no file to parse given. Yeah, okay, like that. That should be a string. Yeah, okay, and then let's. Code should be read to string of the file name. Okay, and then let tokens equals lexer lex code. Print line the tokens like this. Okay, sick. Let's format that one last time. We have 150 lines. Let's hope that this works. I'll end the video if it works. So, okay. What do we have? Can't have. We can't have expected and stir. Oh, we need to, if we do a format here, I think where's that? If we do a format here, we need to s stir, I think it is. Should be it. Let's see. That's it. Okay, and we need to do that everywhere we use this pattern. What is that? Probably need to borrow. Cannot borrow as mutable because That must be mutable. Cool. No file to parse given. That's perfectly fine. We get a lot of complaining about we never use this function. So let's cargo run with powder dev / simple pw. Let's see, IO error. Couldn't find that because it's in the parent directory. What's he complaining about here? Oh. More formatting. Oh, now we get clippy warnings, I think. Yeah, okay. So I'll ignore those for now. I cannot find. Did I mistype that? I named the directory powerdev, didn't I? Okay, yeah, I'll have to do a fix-up commit for that. Let's wait. Here we go. Found word. This is a comment. F found word function of type function. And then we get an explicit panic because we can't handle that. But that looks, I mean, we didn't handle the main correctly. We didn't handle it at all, to be more specific. Let's actually do that, and then I'll end the video. So let's else if let some no, we just like if we have a word and it's not a keyword, it must be an identifier, so we can immediately say okay, we want an identifier. And also I want to put this into quotes so that we can better distinguish what it is. This should say keyword. Don't need that. Let's move all of that, and should be token type identifier. Fantastic. Boom. Identifier main keyword function and the comment, and then we get the panic. Great. So that's basically how a lexer works. Also, if you ever wondered, that's how you do lexers. So I'm not going to commit because I need to do the dumb stupid rename. But yeah, that's basically, I think I'm going to do a bit more lexer stuff off camera, or maybe I'll just do the third video with like finishing up the lexer. But this is like the start of everything. Like at this point we only need to handle more tokens down here, and maybe create some more helper functions, like next integer is probably the next one I'll need to parse the 78 and the 0 and so on. But it will be rather simple, especially like the single character symbols is just like match this symbol, okay, create that specific type. Okay, I'll see you in the next video. Goodbye.